Hello dear students, this time I have come with a very interesting numerical which is demanding to know the change in pH of an acid solution when it is mixed with a basic solution. Of course the concentrations of acids and bases are different. Let's see what the numerical is. It is said that a solution is prepared by mixing 100 ml 0.1 molar acetic acid with 100 ml 0.05 molar NaOH solution. So these two are mixed together. Then what would be the change in pH of an acid solution if its ionization constant value, that is 1.75 10 raised to minus 5. Now the thing that we should keep in mind is that first we need to find the pH of the acid solution whose concentration is 0.1 molar. Now we know that very well that if we ionize acetic acid aqueous solution, adding water, obviously it will ionize into acetate ion, that is CH3COO minus, and into H3O plus, that is H ion. That is there, that we know very well and clear. That will set up an equilibrium and that will allow us to get Ka, that is what we have derived in our previous lectures for finding the ionization constant of an acid. So therefore, with respect to that, we'll find out its H ion concentration, and that is nothing but it is under root of Ka into CO. Now what is the Ka value given to us is 1.75 into 10 raised to minus 5, and that is multiplied with the concentration. What is concentration? 0.1. 0.1 means it can be written as 10 raised to minus 1. So we have substituted the value simply. Now 10 raised to minus 5, 10 raised to minus 1 comes to 10 raised to minus 6. And 1.75 square root comes to 1.322. Fine. So that is 1.322. So that is 1.322 10 raised to minus 6. Now 10 raised to minus 6 is within the root. If you remove the square root, it will be 10 raised to minus 3. So the H ion concentration for this acetic acid is nothing but 1.322 into 10 raised to minus 3. So from this we can find its pH as pH is negative logarithm to the base 10 of H ion concentration. What is H ion concentration? Let's write over here, that is 1.322 into 10 raised to minus 3. So that is equal to, we'll find the log of 1322 with the help of log table. Log table 13, in that we have 2, the value is 1206, and in the mean difference we again have 2, so that has value 6. So we'll add 1206 with 6, that comes to 1212. So I'll write it over here as 1212 for this value. It is a minus sign. Fine, and this minus multiplies with 10 raised to minus 3 comes to plus 3. So this is that. But you know, before decimal there is only one digit, 1. And a protocolic log is to be subtracted, means one digit is to be subtracted from one value, and that comes to 0. So the value of this will be 2.8788. If I am not mistaken. Right, it is correct. So this is the pH of acetic acid solution whose concentration is 0.1 molar. Up to this it is clear. But this is not the whole as far as the numerical concern. We have just found out the actual pH before mixing acetic acid with NaOH. But the solution is to be formed by mixing both the solutions. Now, just keep the things in mind very clearly. Acetic acid is 100 ml 0.1 molar, whereas it is to be mixed with 100 ml but 0.05 molar NaOH, that is a base. Now what we need to do, try to understand. I can say simply that 100 ml 0.1 molar acetic acid means I can write 200 ml 0.05 molar acetic acid. That means I am doubling the volume and I am reducing the concentration to its half. So it will be the same. If I say 100 ml 0.1 molar acetic acid, that is nothing, but it is as good as 200 ml 0.05 molar acetic acid. Why do I do this? Simple. Because here I have basic solution NaOH whose concentration is 0.05 and volume is 100. So that I can compare both by adding both together. So what I'll do, I'll say simply that when 200 ml 0.05 molar acetic acid is added to 100 ml 0.05 molar NaOH, right? The concentrations are same now for both. Okay, but volume is different. This is 200 ml, that is 100 ml. So what will happen? 100 ml 0.05 molar NaOH will get neutralized by 100 ml 0.05 molar acetic acid. That means 100 ml 0.05 molar acetic acid will be remained unreacted. It will remain unreacted. Now what is the total volume? The total volume is 200 ml. And unreacted acid is 0.05 molar. Now as I said earlier, when volume gets doubled, concentration becomes half. So here for total volume when it is 200, the concentration of acetic acid will be half. Half means it is 0.05 molar and half of that will be 0.025 molar when the solution is formed. So this is the actual thing we need to understand, but that is not all. We have to find the change in pH. Okay, so this is the basic equation. Acetic acid plus water gives acetate ion plus H ion. I am writing again this H ion as the subject of formula. So that is nothing but, or Ka as the subject of formula. First let us put Ka, and that is nothing but concentration of H ion to that of acetate ion upon acetic acid. Now what is Ka? Ka is given, that is 1.75 10 raised to minus 5. That is what we are substituting. That is equal to, what is H ion? It is to be found out. So we'll write H ion as it is in the form of, let us say, X. What is acetate ion? Now see, if acetic acid was 0.025 as far as our ionization constant theory concerned, then acetate ion also will be the same because it is for the same acetic acid. So here acetate ion and acetic acid value will be 0.025. So that will be 0.025 upon 0.025. So this two gets cancelled out, and therefore H ion concentration is 1.75 10 raised to minus 5. This H ion is also determined earlier also, but there is a difference. This was before it was mixed with base, and this is after it is mixed with base. So that only can yield us with the change in pH. Now, pH for this can be determined, and that is equal to negative logarithm to the base 10 of H ion concentration. H ion concentration is nothing but it is 1.75 10 raised to minus 5, and that is negative log to the base 10. Now see, let us find the pH value for this. It will be what? This two got cancelled. Fine. So it will be 1.75 10 raised to minus 5. And if we find the pH, it will be 1.75 pH is nothing but we had found out it is 1.322. So we'll write minus 1.322, and negative log to the base 10 of 10 raised to minus 5 will be plus 5. So pH will be 4.3267, and this will be 8. So this is the pH once acetic acid is mixed with NaOH. So this is the change in pH, and if you are asked to find the difference in pH, then it is 4.678, and earlier it was 2.878. So that is 0, 0, 8 and 1. Change or difference in pH is 1.8 and change in pH is 4.678, because acetic acid is mixed with NaOH, obviously its original pH, which was quite acidic, has to get lowered in acidity because it is mixed with a base. So such type of enthusiastic numericals can be approaching you, and then you should face no difficulties in answering them, right? So prepare such type of numericals. If you have any query or question, you can obviously email as you do so, styrene1411@gmail.com, and if you have not yet subscribed for upcoming videos, it is Saurin.S.Mehta Chemistry. You can go for it. Wish you all the very best and prepare well.